This training details the Freeway Facilities module of the Highway Capacity software. This video will detail creating a new analysis, freeway facility segmentation, basic freeway, merge, diverge, weave, and overlap segment details, and results and reporting within HCS. It is important to note that this training was created with HCS 7. With the 2020 publication of the OATS manual, all freeway analysis performed for ODOT must be conducted using the Freeways Facility module in HCS in lieu of analyzing individual freeway elements separately. Analysis of individual elements may fail to capture potential bottleneck impacts at one segment on adjacent upstream and downstream segments. Additionally, the Freeway Facilities method computes performance measures for each of the individual elements as well as for the entire study area. The sample project used in this analysis was the same project detailed during the traffic scoping module. The study area includes the State Route 315 corridor from north of the Bethel Road interchange to the northern ramps at the North Broadway interchange. For the purpose of this training module, only the northbound direction will be modeled in HCS. Similar steps and processes can be used to analyze the southbound direction. The HCS files must be separated by direction, so in this case, there would be one Freeways Facilities file for the northbound direction and second Freeway Facilities file for the southbound direction. After opening HCS, click the Freeways header. Two more options will drop down, Freeways and Reliability. Click on Freeways. Then this screen will open. Under the Start header, click on New File. This process may also be used to open recent files, which will be listed under the Recent header, or Open Other Files by clicking on Open File under the Start header. After clicking on New File, this box will pop up. This is where the analyst is given the option to analyze the freeway elements individually through basic, merge, diverge, or weaving segments, or through the Freeway Facility module. For ODOT projects, facility or facility by segmentation should be selected. This training video will focus on using facility to build the network. For guidance on using facility by segmentation, please refer to the HCS user guide. The project file will open to this blank screen under the General tab. Under the project properties, the analyst should enter the information for the study. The global inputs are helpful when setting a uniform factor across all analysis elements. For example, in the OATS manual, the default peak hour factor of 0.94 should be used for all freeway analysis. Instead of entering the peak hour factor for each individual element, the global inputs allows the analyst to use this page to set the peak hour factor for all elements. However, when first opening the file, there is only one segment. If global inputs are applied at this time, it would only be applied to that segment. Rather, the analyst should wait to apply general inputs until all segments have been entered. Therefore, these global input factors will be entered later in this video. There are no prescribed guidelines on how the project properties information is populated. However, it is encouraged to be as descriptive as possible, especially in the analysis year and the time period analyzed. In this example, the analysis year includes both the year as well as the scenario, which in this case is no build. Similarly, in the time period analyzed, both the peak period, in this case PM, and the direction, which is northbound, are labeled. Proper labeling is especially helpful when multiple directions, alternatives, and analysis years are being evaluated. The next step in the analysis process is to segment the study area. When clicking on the Segments tab, the analyst will see this screen. As previously discussed, there is only one basic segment in this file when it is created. The analyst must add the other elements. The next few slides will detail segmentation. Here's a stick diagram for the sample project. North is to the right on this slide. The figure is not to scale and is just being used for schematic purposes. The first step is to measure between the painted nose of gores for each ramp. The easiest way to do this is by using Google Maps. In this case, the distance between the nose of gore of the North Broadway on-ramp and the Henderson Road off-ramp is 5,320 feet. On either end of the study area, the lengths of the freeway segments should be the distance to the next upstream and downstream ramps. If this length is not long enough to contain the queue on these segments, it may be necessary to expand the study limits. The analyst should contact the Office of Roadway Engineering for direction should this condition occur. The next step in the segmentation process involves determining the merge, diverge, and weave influence areas. This graphic is from Exhibit 10-1 in the Highway Capacity Manual and Figure 6-3 in the OATS Manual. The Highway Capacity Manual methodology establishes a defined influence area of 1,500 feet downstream of the junction with the on-ramp and upstream of the junction with an off-ramp, where interactions with mainline traffic are affected. The influence area of a weaving segment is 500 feet both upstream of the on-ramp and downstream of the off-ramp. These influence areas along the main line are accounted for in the merge, diverge, and weave analysis, not as part of the basic freeway segment. The analyst must calculate the new segmentation lengths accounting for the influence areas. To account for the influence areas, the merge, diverge, and weaving areas must be identified. The merge and diverge sections are indicated in purple on this figure. There is a merge section at the North Broadway on-ramp and the Bethel Road on-ramp. There is a diverge section at the Henderson Road off-ramp. All of these sections are 1,500 feet. There is a weave section between the Henderson Road on-ramp and Bethel Road off-ramp. The influence area for each side of the weave area is 500 feet. So, identifying the segments, start with the 4,720-foot segment on the southern end of the study area on the left side of this diagram. That segment will be a basic freeway segment. Then, there will be the 1,500-foot merge segment for the North Broadway on-ramp. Next, the basic freeway segment between the North Broadway on-ramp and the Henderson Road off-ramp is not the 5,230 as originally measured, because there is a merge segment on the upstream section and a diverge segment on the downstream portion. The new length of the basic freeway section is 2,320 feet, which is the original 5,230 less 1,500 feet from the North Broadway merge influence area and 1,500 from the Henderson Road diverge influence area. Then there is the 1,500-foot diverge section to Henderson Road. Now, the weaving segment between Henderson Road and Bethel Road has influence areas of 500 feet both upstream and downstream of the weaving segment. Therefore, the basic freeway segment between the Henderson Road ramps is the original 2,200 feet less 500 feet, which is 1,700 feet. The length of the weaving section shown in green is the originally measured 1,720 feet plus 500 feet for the downstream section and 500 feet for the upstream section, resulting in a total weaving segment length of 2,720 feet. The section between the Bethel Road ramps is a basic freeway segment. The length is the originally measured 2,480 feet less the 500 feet that is part of the weaving segment. The new length of this segment is 1,980 feet. Then, there is the 1,500-foot merge section from the Bethel Road on-ramp, shown here in purple. Lastly, the northernmost section will be the original 7,500-foot basic freeway segment minus the 1,500-foot merge section from the Bethel Road on-ramp, or 6,000 feet. In total, this project has 9 segments, 5 basic freeway sections, 2 merge sections, 1 diverge section, and 1 weaving section. Now that the study area has been segmented, we can go back to HCS. The first step under the Segments tab is to put in the start time. The specific start time does not need to be coordinated with the actual peak hour. Defaults of 700 and 1700 can be used for the AM and PM peak hours, respectively. For example, even if the PM peak hour is from 5:15 to 6:15, it is acceptable to put the start time in HCS as 1700, as long as the hourly volumes inputted into the program are from 5:15 to 6:15. The time in HCS does not matter. It is just helpful to be able to distinguish between analysis periods within the HCS files. In the first segment, the type is Basic Freeway. The name for the segment should be entered. In this case, it is northbound State Route 315 south of North Broadway on-ramp. As previously discussed, the length of this segment will be the distance to the upstream ramp, in this case 4,720 feet. There are 3 lanes in this section. The demand is 5,570 vehicles per hour. Next, to add another segment, click on Add Segment. This will add a new segment below the first one. Now we will build the Merge segment. In the drop-down menu, there are multiple options including the Merge option. After identifying the section as a Merge segment, the analyst only has to provide the name of the element, which in this case is North Broadway on-ramp. The length is automatically entered as 1,500 feet, and the number of lanes is still 3 because it represents the number of mainline roadway lanes, not the number of lanes on the ramp. The demand cannot be modified within this window. It is automatically calculated based on the inputs in the Details tab. These inputs will be covered shortly as part of this training module. Once the basic freeway segment between the North Broadway on-ramp and the Henderson Road off-ramp has been entered, the fourth element is the Diverge segment to the Henderson Road off-ramp. Again, the length is automatically determined to be 1,500 feet. The basic freeway segment south of the Henderson on-ramp can then be entered. The next segment is the Weaving segment. Similar to the Diverge and Merge segments, Weaving is an option on the drop-down for analysis type. The distance for this segment must be entered as there are no assumed distances like the Merge and Diverge segments. In this case, the number of lanes on this segment is 4 instead of 3 because of the auxiliary lane, which is contributing to the weave. Here's the completed segmentation in HCS. All 9 segments have been entered, and the graphic correctly illustrates the study network. Before moving on, it is important to discuss an instance where segmentation may not be as straightforward as presented in this example. An overlap area occurs when there is no auxiliary lane between an on-ramp and off-ramp, but they are closely spaced, at least 1,500 feet, but less than 3,000 feet, so that the influence areas overlap. This is illustrated in this figure. The distance between the 2 ramps is only 2,400 feet. There is an overlap of 600 feet. Therefore, when entering this location into HCS, there would be 3 segments: a 900-foot merge segment, a 600-foot overlap segment, and a 900-foot diverge segment. Notice that these merge and diverge segment lengths differ from the default 1,500 feet and will need to be manually entered into HCS. When entered correctly, the overlap length plus the merge or diverge length will equal 1,500 feet. Here's what this situation would look like after being coded into HCS, including upstream and downstream basic freeway segments. Notice that the segment between the merge and diverge sections is not labeled as a basic freeway, but rather as an overlap segment. Now that segments have been created for the study area, we can revisit the global factors inputs on the General tab. The following global factors may be useful to modify. First, the area type is easily modified on this tab. The program defaults to an urban area type, so if a rural freeway is being analyzed, this factor will need to be changed. Next, the freeway lanes can be set in this window if they were not set as part of the segmentation process. It is important to note that if the checkbox was selected for the number of freeway lanes, all segments will be modified to have 3 lanes, including the weaving section, which currently has 4 lanes. If this button is toggled, the analyst should review the configurations under the Details tab before performing the analysis to ensure that the number of freeway lanes are properly coded. The freeway free flow speed and peak hour factor are default values as defined in the OATS manual, and the truck percentage for the freeway segments can be determined from count data. Similarly, the number of ramp lanes can be set globally, but care should be given to ensure that this factor is coded correctly under the Details tab. The ramp free flow speed is the free flow speed of the vehicle at the merge or diverge point. For the purposes of ODOT analysis, this value for most ramps is 15 miles per hour below the freeway free flow speed. In this case, the ramp free flow speed is 55 miles per hour. The free flow speed of loop ramps could be lower than this default value, and the free flow speed at system ramps could be higher than this value. The ramp peak hour factors depend on the ramp terminal intersection, so typically this value would not be set globally. Lastly, the truck percentages for the ramp can also be set globally. When all of the global inputs have been selected and defined, click the button to apply the global inputs. The next step in the analysis is to enter the segment-specific data under the Details tab. The top portion of this window allows the analyst to select which segment is being detailed. In this case, the first basic Freeway segment is highlighted, and the segment at the top of the page also indicates this is segment 1. Under the Geometric Data header, the only input is to check the box by Measured Free Flow Speed because ODOT defines that a default free flow speed be used. Because Measured Free Flow Speed has been toggled, the lane width and right side clearance values are not entered. If necessary, grade information for the segment would be provided here as well. Provided all other data was entered on the General or Segments tab, the Geometric Data section is complete. Moving down the page, the only input under the Demand Data and Adjustment Factors is the demand volume. The peak hour factor and total truck percentage may be changed on this screen, but they were likely set as part of the global factors. Default values for adjustment factors should be used. Next, we'll input details for the merge segment. The analyst may move from segment to segment by clicking on it in the diagram or by using the drop-down menu at the top of the page. Provided the information has been entered in the General or Segments tabs, the analyst should be only required to modify the number of lanes on the ramp. Select the side of the freeway from which the ramp merges, and provide the length of the acceleration lane. The acceleration lane length is measured from the painted nose of the gore to the end of the taper as illustrated here. Assuming that the other data has been input as part of the General or Segment tabs, the only inputs under the Demand Data and Adjustment Factors headings are the Merge Demand Volume and the Ramp Peak Hour Factor. Notice the Freeway demand box is grayed out and cannot be changed under the Merge Segment analysis. If different from the global factors, Freeway total truck percentage and Ramp total truck percentage can be entered. Again, the use of adjustment factors will be very limited on ODOT projects. The default values should be used. Diverge segments inputs are nearly identical to merge segments. The number of ramp lanes should be specified as well as the side of the freeway the ramp diverges from and provide the length of deceleration lane. The length of the deceleration lane is measured the same as an acceleration lane, beginning of taper to the painted nose of the gore. The length of the deceleration lane is measured the same as an acceleration lane, beginning of taper to the painted nose of the gore. The only inputs under Demand Data and Adjustment Factors for diverge segments are the diverge demand and the ramp peak hour factor. Again, notice how the freeway demand box is grayed out and cannot be changed on this screen. If different from the global factors, freeway total truck percentage and ramp total truck percentage can be entered. There are several inputs required for a weaving segment. First, under the freeway geometric data, the weaving configuration must be entered. In most cases, the weave will be one-sided. Based on the number of lanes on the freeway and the weaving configuration, the number of maneuver lanes, minimum number of freeway to ramp lane changes, ramp to freeway lane changes, and ramp to ramp lane changes will be automatically calculated by the program. The other input on this screen is the short length. The short length of a weaving section is measured between channelized lanes or barriers as shown here. This length is irrespective of the location of the painted nose of gore. Two weaving segments could be identical in length between painted gores but have different short lengths because one segment has longer channelizing lanes than the other. Under the ramp geometric data, the number of lanes for both the on and off ramps should be entered. There are multiple volume inputs required under the demand data. The ramp to freeway, ramp to ramp, and freeway to ramp demand is required for analysis as well as their corresponding peak hour factors and total truck percentages. The other inputs should have been entered under the General or Segments tabs or are default values. Now that all of the analysis inputs have been entered, we can view the results under the Results tab. This tab shows the performance of each individual element. Similar to the Details tab, by clicking on the segment in the diagram or using the drop-down box at the top of the page, analysis results can be viewed by segment. A useful feature of the HCS Freeway Facilities module is its ability to provide graphical results. Here are the results for flow, speed, density, and level of service for the sample project. The colors, especially the shades of red, are very helpful to visually see where slowdowns and bottlenecks may be occurring within the study area. As detailed in the OATS manual, the results from the HCS analysis must be included in the appendix of the analysis report. There are several reporting options under the Report tab. The default report is the Freeway Facilities Report. This report should be printed and included as part of the appendix. Results for all of the segments are included in this report as well as overall facility results. Graphs of the volume, speed, and density distributions are also provided. The reports for the individual segments must also be printed and included in the study appendix. These reports are obtained by clicking Switch to Segment Report at the bottom of the report window. To change the segment being reported, click on the drop-down menu on the bottom of the page. One thing that should be noted with this analysis is the message that was included as part of the Freeway's Facilities Report. It said that oversaturated conditions currently exist in boundary time period 1. Results may not be reliable. Consider expanding analysis in time and/or space to resolve this warning. As detailed in the OATS manual, only single-period analysis is being used for ODOT projects at this time. Therefore, this error is unresolvable and the results are acceptable for ODOT analysis. However, the analysts should be aware of the effects this oversaturation has on results for the no-build and build alternatives. Assume a proposed solution involved adding an auxiliary lane between the North Broadway on-ramp and Henderson Road off-ramp. This segment would be analyzed as a weave. Therefore, there will only be 7 segments in the build condition compared to the 9 in the no-build. However, the length of the project is constant between alternatives. Looking at the flow graphics, it is apparent in the no-build condition that a bottleneck exists on the southern end of the project. This bottleneck is metering the traffic able to reach the northern limits of the study area. As a result, the operations on the northernmost segment, or segment 9, in the no-build condition is LOS-D, despite the fact that the demand-to-capacity ratio is 0.97. In the build condition, the bottleneck is removed and the full demand can reach the northernmost segment, or segment 7. As a result, this segment operates at level of service E. While no geometric modifications were made to this segment, there is more traffic arriving at this segment during the analysis period, which results in a lower level of service. The demand-to-capacity ratio is 0.97, the same as the no-build. The fact the LOS has lowered is an indication that the build condition has improved upstream operations. The fact that the build condition did not receive the error regarding oversaturated conditions is also an indication that the build condition is an improvement over the no-build. Care should be taken when comparing the overall facility results when at least one alternative is oversaturated. Because of the bottleneck in the no-build condition, the downstream segments operate with a higher speed and lower density than the build condition. However, the overall facility LOS can be compared. For this example, the facility LOS improved from LOS-F in the no-build to LOS-E in the build. In summary, this module described the process for analyzing freeway facilities using HCS. The configurations covered in the Facilities module cover the most encountered configurations. Please contact ORE for situations not covered by the training. We will provide future OATS updates to show those situations. For more information, refer to the OATS manual and some of the other online training modules.